Hey everybody, what we're going to do today is a little bit different than most of the videos. It's going to have Emacs content, but it's really going to be about ClojureScript. So it's going to more be, I'll be using Emacs in conjunction with creating a ClojureScript application. We'll be using a couple of packages that I haven't played with on videos before, Smart Parens and CIDER, but it's really about ClojureScript, and I'm going to share this with the ClojureScript community and see if there's any interest in me doing a few more along these lines. I'm by no means a ClojureScript expert. I'm learning it as I go, but I'm finding that I'm finding it difficult to find resources. The community is great and there are some terrific resources, but just in terms of tooling and getting things together, I think it partially suffers from the problem of there's more than one way to do it. So hopefully I can help put things together, and if people enjoy this and find value, I will do a few others, and I'll mention what at the end of this video. In fact, I think this video will probably be longer than my usual videos, and I'll probably even break it up into a couple of parts if necessary. So basically, I used to use JavaScript, like everybody, for web development, and it started out vanilla JavaScript, then it was, jQuery and the various other frameworks way back when. I remember one of them that I used, their motto was, we make JavaScript suck less. I'm blanking on the name for that one, but jQuery won that round and took over everything. Since then, I've moved to, I didn't do web development for a while. And again, this is all as a hobbyist. Then I came back, and all of a sudden the new hotness was React. And the idea of the virtual DOM and the efficiency and all that was really cool. But it was kind of more of the flavor, it seems similar in terms of from the programming point of view, from stuff that was before. It was a little bit too magical. I prefer the backbone approach than like the React or the Angular, or I forget the other competitors at the time approach. And React had that. And also React still had the problem of you had JavaScript and HTML all together, and it was a mishmash. And in the HTML, you had certain magic markup that would put in JavaScript values and certain magic incantations to do very rudimentary programming. But it was still this Frankenstein's monster going on. Anyway, I landed on Vue.js, which felt more to my liking, but it still had some of the same issues. Then Clojure came along. Clojure was around, but I started playing with Clojure and started looking into ClojureScript. And I'm really liking ClojureScript for web development, and for a number of reasons. But the tooling was a problem. And then I discovered Shadow CLJS, and we'll bring up the website here. And this seems to be a nice go. What it does, it's a build system for ClojureScript that allows you to target the browser or node. And I've used it to do some browser applications, really simple, small stuff like, Conway's Game of Life stuff, really just toys, but also a little Electron app. It just seems to work for me, and it has really nice documentation. So I thought I would do a walkthrough as to why I like ClojureScript for web development, or why I'm liking it so far, and maybe put some of these things, the little pieces together to make it clearer for people. And so I started, I made this little Shadow CLJS template repository on GitHub, and I went to the settings and I made it a template repository. And the reason why I did that is because now I can use it for other projects. So if you don't know about template repos, it's really cool. So normally you would clone this or whatever, or fork this or whatever. But before that, I'm going to use it as a template, and I'm going to make a new repo. I'm going to call it Shadow CLJS Demo. And what it's doing is it's making, it's kind of like a fork, but it doesn't go back to the original. It's just like a new repo using that template. So if you've got all this boilerplate template code, it's just a nice way to get started. So that's a really nice new GitHub feature, relatively new. So let's clone this. And so I'm in temp here, so I'm going to clone this. And I've got some, make this even bigger. So I've got basically, let's look at this directory structure. Let's look it up. We can look at it here as well. It doesn't matter. So I've got package lock JSON, and that was created automatically in the setting up everything. And I've got Shadow CLJS .edn, and this is my shadow config. We'll look at that shortly as well. And then package.json. Now package.json, this controls the JavaScript world. This is for NPM managing the project. And if you want, let's go into another directory. I can just do npm init, and you can just read through this and just hit a bunch of enters, yes, and cat package.json, and you get a bare bones version of it. But this one, ours, has a little bit more information in it. And I got this, most of this was generated automatically, or I copied it or whatever. And incidentally, if you need to install NPM or Node for this, I use the Node version manager. I use Node version manager. You can just search for it and install it, and then it's pretty straightforward to do to set that up. But anyway, so name about the project, and then script. So I'll talk about this. This was in the sample that I copied over. I'm using Tailwind for my CSS, and so for Tailwind you have to build your CSS each time. So this command, npx, which is installed with npm, Tailwind build, where my source is and where my target is. So if I look at this is just the basic Tailwind. If you look at the Tailwind site, if you like this, the documentation says make this file. And target is where I'm ultimately going to build my application, and this is all the stuff it creates. This next line, Tailwind, this watch, lets npm watch this Tailwind folder for CSS files, and every time they change, it reruns Tailwind. So if I do npm run watch CSS, well, I haven't installed anything yet, so we'll come back to this in a second. It will watch the CSS. We'll come back there. This stuff I just copied, boilerplate stuff. But here's the important stuff. Since I'm doing shadow CLJS, I'm doing ClojureScript, I'm going to be using Reagent, which is a wrapper around React. So these are the packages that I need, React and React DOM, and I think I need create React class. The way I got these, let's just go back to this temp directory. I can do npm install -- save, and I can say React and React DOM. And notice that it created that package lock JSON, but it also put in the latest versions of these into my package JSON. So you can always do that if you want to get, if you want to just set this up yourself. And I also installed the npm install saved Tailwind CSS, which I need for my CSS. So I'm going to do an npm install, and that's going to install everything that's in those files in that package JSON. And now if I do npm run tw, it'll run that Tailwind script, which will build it once. But if I run watch CSS, it should be watch CSS. Do I have to install something? Yeah, I forgot to install onChange, so I'll update my template later with that. I'm not going to use that for the rest of this demo, so that's okay. So anyway, so then the next file that we have that's important is shadow CLJS EDN, and this controls everything. So basically, my source path is source. So if I look here, I've got my ClojureScript file in there. Now I can give multiple paths for that and a more elaborate one. And if you look at the shadow CLJS manual, it'll go into details on that. But I'm just dumping it in source. These are my dependencies, ClojureScript dependencies. So reagent, core async, which I use. And then this is for logging. I'm just starting to play with it. Now here, this is where if I'm running a dev, if I'm running dev on this for development, it'll start my server on 8080. And then this is my build, and I can have multiple builds. So this build app has a target of target, so that's going to put all my stuff into target. My asset path, dot, that's where to look for my assets, so I can put like images and whatever else off of this. I'm targeting a browser, so a browser application, not a node application. My modules, main, and so that's under that source directory, main CLJS. This is the thing to load. This is my main function to load. And I copied this, I think, from the Shadow CLJS apps. And then if I reload from my dev tools, when I change it, it's going to rerun, it's going to reload the page and load reload. Target goes to target, HTTP port, same thing. So I can actually, if I do Shadow CLJS, and I did an npm install -g for global, Shadow CLJS earlier on to install Shadow CLJS globally, but you can also just install it locally, and you can also install it with the save option. But I've already done that. So if I do Shadow CLJS, that's not going to do anything yet. It's just updating my dependencies. So give this a second. But I can run different commands here, so I can watch, and that's going to build and keep watching this, but I can also compile if I just want to build this. So Shadow CLJS build compile app. And this will actually compile the application. So just give this a second, and we'll get to the cool stuff in a minute. I know this is going on of 10 minutes of overview, but when I was trying to figure this out, I would have found it helpful for me to have kind of this mapping of where everything lives and what everything does, so I'm hoping other people find the same. So now you'll see I've got node modules for my installs. If I look at my target, it's got all my stuff in there. So it's created main.js, and that's another thing I haven't shown you yet, which is, let's go to temp shadow target index. This is something else that I've started with, is we've got our HTML file, which loads this, which sets this all up, and notice that I'm just loading this main CSS, under target, under here, created by Tailwind. And this is your Tailwind classes. And then I'm just having my little app here, my little div, which the ClojureScript is going to inject. But I can also do Shadow CLJS, and this built it, and I can watch the app build. And while that's building, I'm going to go into my source, main CLJS, and this is my ClojureScript file, and you'll notice that it's doing things differently than JavaScript. So to start with, notice div h1, so my HTML is written differently. I'm actually going to open the web page now, localhost 8080, and there we have it. You know, this is a component, so if we change this, this is a comment, and it changes. Woohoo! Okay, everything is really cool. So it works and it reloads, but I'm not really using Emacs in any interesting way yet. I'm just editing it, and I have something watching my app. So I'm going to break out of that, close that, and to jump into the Emacs side, and then I'll talk about this creating, you know, how we do it in ClojureScript. I'm going to use CIDER, and CIDER jack in. I could just do CIDER to get into CIDER mode to start with, but I'm just going to do CIDER jack in, CLJS. And that's going to start CIDER and start my CIDER REPL server, everything, blah, blah, blah. So I hit enter there. This is the last time we're going to have to load this, so I promise, last time we have to do all this waiting. And CIDER supports all these different things for ClojureScript. We're going to do Shadow because we're using Shadow CLJS. And I'm going to choose app because that's the application that I want to watch, not these guys. If you don't see app here, there's something wrong in your configuration file. Start a browser on localhost. Boom, we got it. It's not set up, it's not synced yet. So, whoops, component. Not synced yet. Let us reload this. Now it says component from ClojureScript. Okay, and we're good. Now you can use the menus for everything here, so you can do all this stuff. What I just like doing here is I just like going into the namespace that I'm working on. So namespace main. And now we can start working. So there's some really cool things going on what I like. First, notice how we do the HTML differently. And let's, one of the things is, if we go back to index, with index HTML, notice that we've got the beginning and the end. Div beginning, div end. If we want to have a list, we can have an ordered list and and this doesn't reload because ClojureScript is not watching the main HTML. It's just watching the ClojureScript side of it. And this is this, but notice that it's beginning, stuff, end. And we can put stuff in it like classes, like, so class equals text XL3. I don't think that works. I'm going to look up text size here under Tailwind, text size. And I love text. Okay, so it's, I'd love to get completion on this in Emacs, and I haven't figured that out yet. So let's look at text size. Text to XL. Oh, and actually we don't know. Yeah, okay, so anyway, and we can put classes in here, and then we put other features in here, etc. But I find it much cleaner to do it in this, if you think about in Clojure, this is a vector. And in a vector, we have stuff. And so one of the things here is, we have div beginning end. And so one of the things we can do is we can then say, and this is the way Hiccup, which is the way ClojureScript does this, we can say, for our class, we'd like, text 2XL, and now it's a little bit bigger, or 4XL, font bold, and these are Tailwind stuff. And so we can just add these components in the brackets there, and it's just a vector. And one of the nice things that we've got, another nice thing we have is we have this shorthand text for, let's go 2XL, 4XL, font bold. And so we can use that shorthand, which is kind of like an Emmet mode shorthand as well. And it's very easy, it's just all Clojure. Now this makes things to me much easier to actually manage. So let's do something else here. I guess it's kind of gratuitous. Let's make more of a way. And then just to look at the full thing here, whenever we reload, if we look over here, go back to here, when we reload the page, it's saying hello reload. So, even if we go to 2XL, we get a hello reload here. And also, we see it down here. So notice that it's all connected. So let's do the gratuitous example of putting a counter in here. So I'm going to make a counter, which is going to be a reagent atom starting at 0. And notice that I get the automatic bracketing here, also for that. That's smart parens. And for smart parens, you can also do things like, if you mark something and then do, hit the bracket symbol, it's like 1, 2, 3, and then it brackets all of it, which is really kind of nice. So an atom, it's just, an atomic data item that you can kind of control when you're in a multi-threaded environment, how it changes. So, because remember in Clojure and ClojureScript, everything is normally immutable. So if you're going to have a mutable or changeable value, you want to be able to make sure things happen in a controlled environment, atomic environment, etc. And I'm using the reagent atom from the reagent library because I've imported reagent as R. And so let's make another, let's make it, an H1. Let's make it text 4XL. Font bold again, and we're just going to dereference the counter and put that there. And let's add a little padding to move it over a little bit. And so we can change this however we want. We can also then put in stuff like on click, we can do something for it. So every time we click, we can run. This is an anonymous function. We can print hello. So on click, we print hello, we say we're printing it multiple times, we print hello, but more valuably, we can change, we can swap, and in in Clojure, taking from Lisp, the exclamation point indicates, hey, we're changing something, changing a value, we're mutating something. And we're going to change the counter by running the increment function on it. And now we've got our little counter. Woohoo, okay. So we can do more with this. We can get sillier with this. So another thing we can do is we can change the background color. We can do it here, but let's just do it up here in a class. We can say, let's make a class BG green 600. And now that's too bright. Green 400. And notice we get those error messages there. So one of the nice things I like here is this is just a vector. It's just ClojureScript where we can put functions and data. It's all the same. That's the big deal. So we can just embed our, like let's say we want to say, well, I don't know, if my counter, and that at dereferences the counter, if I go here and I look at counter, it's an atom. But if I dereference the counter, it's just the value in the atom. If the value is less than 10, let's make it background green 400. Otherwise, let's make it background red 400. Close the paren. Now, incidentally, if I were doing this using smart parens strict mode, it wouldn't have let me get rid of that close paren that I deleted accidentally. Strict mode, I'll talk about strict mode in a little bit or in a later video. So notice now, ooh, it's red, okay. But I want to show something else here. Notice that every time I change something, it reloads the page. And that's your normal behavior for most of these types of, REPL, not REPL, but most of these types of live coding development. But you don't necessarily want to do that. So like, let's say we want to make it, we've reloaded the page. Let's say we want to just insert or change values in the page. So we make this, it goes up to 13. And let's say, I don't like that. So why don't we say swap or reset. Now what swap does, when we did swap the counter, then we run a function that does something, and then the result goes in the counter. Reset just puts the value into it. And so notice that it's still running, it just changed it. It didn't reset it to 0. It didn't reload the page to 0. Or even with this, let's say I don't want this red, I want this orange. I can just hit Control-C, Control-C, and notice that that reruns that component, and then I can mount main component again. And notice all this completion that I'm getting. Now I've remounted it, but it didn't reload. This is 6, 7, 8, 9, 10, and then I made a mistake. What was my mistake? I misspelled orange. So if I do that, and notice it's 11, and I remount the page, and it hasn't reloaded anything. It hasn't reset my state. This is very, very valuable when you want to do things like, when you're debugging or developing and you want to try things within your program as it's going. So another thing I'll show is, notice that I did that Control-C, Control-C thing here. I prefer the red, so let's go with that. I'll just reload it. You can also notice that I did Control-C, Control-C. But I can also evaluate the last S expression. There are different ways I can do my evaluation. So like I can be like, oh, I just want to evaluate this if statement, and I don't do this one as much. So that should be the last so that could be say XE. So Control-X, Control-E, and notice that it evaluated to green 400. But if I reset my counter to 15. And I do this, it does to red 400. So I can even do little tests inside of my code. Really, really nice feature. I really like CIDER for this. So just to show a couple other things that we can do, another thing with this embedding is I've made this H1. I can even do stuff like, let's make a ordered list. And in that ordered list, let's do for item, and let's say we want to do range 10. Okay, so we don't want to do range counter. And what that's going to do is it's going to go give me a range for a counter, and we'll do a list item and item on that. And I probably have a mistake on this. And that, and notice what I just did is I slurped this, and I didn't know if that's quite right. Let's see. That's probably not right. That's another smart parens thing, but no, that's actually okay. I want to move that into a vector, so let's see about that. Let's go into an empty vector. Int, not int, into. Oh, actually, I don't want to make this into a vector. I want to actually not have that as vectors. So I'm forgetting how to do this here. Come out, we don't need to do this. So I'll just show you another feature. I can just get rid of the entire S expression, and it is gone. Do I want to play with this more here? Oh, well, duh. So I can go back to here. Let's come up to here. Let's go with this. What we want to do is we want to put this into OL. And now, let's see. Put that into the div. There we go. Actually, I'm not exactly sure what. Oh, interrange, fine. Counter. There we go. So notice that we can just write our ClojureScript, and it just works. We can modify it by, let's say, dash padding 4, so we can do that and move that over. Okay, so really, really cool. So there's one more thing that I want to show for today. And then if people want, I'll just mention what I'm thinking about doing in the future if people find this valuable. And if they don't, then I won't bother. But the other thing here is, when you're working in JavaScript normally, and things like React and Vue have solved these problems in their own way, you don't want to get into these situations where you're just kind of calling things directly based on events, and you're just modifying state all over the place. You want to do it in a more controlled environment, and that's where this core async comes in. We can set up a channel. So we're going to make an event queue, and it's going to be a channel. And a channel just will sit and wait for stuff if you set it up to do so. And so we'll make a little wait for our channel here. So we can just say, we'll use a go loop. And so this is going to make a little thread. So it'll be separate, and it'll just wait for stuff. It'll wait for stuff off that queue. And the way we do that is we're going to wait for an event, which will come from the event queue. And what we're going to do is let's just print out the event. So we just reran this, and we can come down here and we can say, let's put onto the event queue hello. And well, then I have to finish this. I have to, if I do this again, it's not going to print out the second one. Why? Because I didn't recur and say, let's make the next event is going to be the next event off the event queue. So now if we put hello, hello, goodbye, whatever, and we're just using keywords in Clojure for this. But we're going to process the events here, so we'll use a case statement for this. And on the event, we'll say if the event is increment, let's swap in the counter with the function inc, and decrement, let's swap with the counter dec. And then here, instead of doing swap, we're just going to what are we going to do? We're going to put onto the event queue increment. So now it works the exact same way, except we can also, from other places, put onto our event queue decrement, and that decrements our counter. And we can do even better than this. What I like doing is, instead of doing just an event, I'm going to destructure by saying I'm going to get an event and a payload. And so here, instead of doing an increment, I'm going to do an anonymous function. And the anonymous function is going to add to the parameter of the anonymous function. If you have multiple parameters, you number them. We're going to add the payload. And this one here is going to be subtract from that the payload. And very simply here, we are going to put onto the event queue an increment, and let's make an increment of 3. So now every time we do it, it goes up by 3, or we can make it an increment of 1 every time it goes up by 1, you know, so we can, oh yeah, okay. But on the other hand, we can just put onto our event queue, and we'll put a value of, and we'll put a vector saying decrement by 5. And let's do that again, and we're good. So basically, I hope this gives a little flavor. I've been using a little bit, not much Emacs, but CIDER, how it works. You know, the other thing I'll show is if I do go to smart paren strict mode, notice that if I get rid of something, like it makes sure I'm balanced, so my cut and paste automatically goes for full S expression. I might start using that, but right now I'm not. I'm happy with just using the regular, you know, and then I can cut and paste, and it doesn't do that. But what I can just do is I've got it set to control meta kill to do the S expression. If people are interested, let me know in the comments. I'd be happy to show what I thought I was going to get to, but I'm not going to here, is, you know, how we can do, like how you can start building out components. I like Tailwind with ClojureScript because of the code is data, data is code, and Tailwind just uses these little utilities to build components. So like, well, how do you make an input field with label as a reusable component? How do you know, that type of thing. You know, also I was thinking that it might be useful to go through the pains that I had coming up with how to do an Electron app. And even the other big one is, you know, how I've been working on doing the server side and the, you know, using Shadow CLJS for the server side stuff, but something else, or rather for the client side stuff, but other stuff for the server side stuff. So what I'm going to do is let's go to Magit. Let's put everything up. You know, got part 1 of demo going, and we'll push this up to GitHub so it's there for the next time if we want to use it. I'm not saying that I know the right way of doing any of this, so if you know, if this is not idiomatic or the best way, please also leave in the comments. But you know, please do it nicely, and let me know if we should be making a few more of these. And yeah, so thanks for watching, and yeah, enjoy.